This video will discuss Chapter 11 Factorial Designs, in particular, higher order factorial designs. So when we talk about higher order factorial designs, these designs are going to involve 3 or more factors. So the other videos and earlier in the chapter, all we discussed really were 2-factor designs for simplicity to help us understand the differences between those main effects and those interactions. Now a higher order is going to have more variables, and you see here we have a 2 by 2 by 2. A 2 by 2 by 2, remember this is, in terms of independent variables, this is one independent variable, a second independent variable, and a third independent variable. And the levels, and each one of these, so this first independent variable has 2 levels, this second independent variable has 2 levels, this third independent variable has 2 levels. For example, let's say our first independent variable we'll call factor A, and we'll say that it's mnemonic device. So I'm going off of this is basically my senior project that I talked about in a previous video, the experiment that I did for the most part. And so mnemonic device is our first factor, and it has 2 levels. Factor B would be this next factor here, the second independent variable, and it had 2 levels, gender, which is 1, and male, which is 1, and female, which is 2. So 2 levels of our second independent variable, factor B. And then we have factor C, again, so this would be our third independent variable. We have spatial ability, and it again has 2 levels, high and low. And so what I did here in this experiment way back when was we basically said, we gave instructions for people to use a mnemonic device to remember words, or we gave them no instructions. We also gave them a spatial ability test, and we dichotomized that, and we said, okay, these people have high spatial ability and these people have low spatial ability. So that one was a quasi-experimental independent variable. And then we also used gender because we thought the spatial ability might differ based on gender, and so we were looking at that as well. So we had 3 main effects, 3 two-way interactions, and a 3-way interaction. So that's quite a bit. So we had a main effect of A. We had a main effect of B. We had a main effect of C. And then we had an A by B interaction, a B by C interaction, an A by C interaction, and an A by B by C interaction. Very complicated. So what type of statistical analysis do we do for these factorial designs? And really it kind of depends on what the factors are. Are they between subjects? Are they within subjects, or is it some mixture of between and within? So standard practice is going to include computing the mean for each treatment condition or cell and using ANOVA to evaluate the statistical significance of those mean differences. And so that's kind of the basic overall way that factorial designs are analyzed, but it depends on what design you have as to which statistical analysis that you actually use, which type of ANOVA that you use. So for between subjects, an independent measures 2-factor ANOVA would be the type of analysis that you would use, or 2-factor or more ANOVA, basically. If you have a within subjects design, you would use a repeated measures 2-factor ANOVA. And hopefully this makes sense to you. We've talked about some of this before, right? We've talked about how between subjects we call it also independent measures. But now we can't use a simple one-way ANOVA. We have to use a factorial ANOVA. And so for this, we'd have a 2-factor ANOVA that we would use. We've talked about within subjects, we also call that repeated measures. And so just like for a 1-factor design, when you have you would use a one-way repeated measure ANOVA, now we need to use a repeated measures 2-factor ANOVA if we have 2 factors or more. And if we have some mixture of between and within, we use a mixed design two-factor ANOVA. And so different statistical packages will have some of these things worded differently. And we'll come back and try to run one of these, probably the independent measures two-factor ANOVA at some point between now and the end of the semester. But I want you to have practice working on those labs and interpreting those main effects and interactions before I have you run that on SPSS.